Morning, everybody. We're going to wait a few minutes until all the participants, attendees are in. They're slowly to trickle in. So, we'd just like to remind you that we do have a Q&A button on the Zoom controls. So please use the Q&A so that we can track the questions. We still have a few more people coming in. Just give them a few more minutes, and then we'll get going. Netherlands, hey, my namesake. Spain, Washington, D.C., Mexico, Bangladesh, Costa Rica, Sacramento, Ireland, oh, one of my favorite countries to visit. All right, we're hitting 59 attendees. Let's see, and 130 some people registered, and we're at half. And it's getting time to start, so. All right. Good morning, good afternoon, hello, whatever time it is for you. We're hoping you're having a great day. My name is Wayne Van Sluis. I'll be your host and one of your speakers today. I'm a senior lead consultant with Argano. We're Oracle here, joined by David Lapp, and we'll get into our bios in a minute. But just again, wanted to welcome you to our webcast. So as I said, I'm a senior lead consultant with Argano. I've been doing data analytics for nearly 25 years. Have been recently, I would say in the last 5 years, been working with spatial analytics as well, and adding maps to my dashboards and my database projects. And David, would you like to introduce yourself?
Yep, thanks, Wayne. David Lapp, I'm a product manager for spatial and graph technologies at Oracle. And so that sort of covers everything we do with Oracle Spatial in the database and things we do with other product teams, and work closely with the analytics teams and great partners like Wayne. So thanks, Wayne, for having me join.
Deal. All right. So just as a reminder, we do I'll probably about bi-weekly tech casts out to on various topics, and you can take a look at our website, andouc.org. Go to the TechCast panel and look at the ones back to 2019. We did a preview of the A&D Summit, which is coming this March, last December, and we will do another preview in 2 weeks about some of the topics that we're really looking forward to at the A&D Summit in March. And speaking of which, the A&D Summit in March, it'll be March 14th to the 16th at the Oracle Conference Center in Redwood Shores. Use the QR code on the left, and that'll bring you right to the Summit registration site. Just a reminder that our early bird registration discount ends at the end of this month. So I would recommend, if you want to save some money, click that and get registered before the end of the month. And you know, I love some of this merch that we have, and it's just a way to help keep the organization some reserves and money for the organization to operate. We are a nonprofit, and you know, membership support, we don't have a fee yet, and using this merch kind of helps offset some of our costs. And we would love it if you would buy some. There's some great stuff out there, so take a look at our store. For those of you who like to follow people on social media, we do have quite a few channels in which to follow us. We do have the YouTube channel where all tech casts and any kind of recordings that we do are posted. We have Facebook, LinkedIn, Twitter, and of course the website, and then of course the Slack channel where you can ask questions and people discuss amongst the topics. So take a look at all those. It'd be great that we can connect with you on any one of those. So without further ado, let's get into the meat of why you guys are here instead of an advertisement. Today we're going to look at, and I'm going to turn off my camera so that you're not seeing the side of my face when I'm looking at my other screen where I can read things better. So today we're going to look at the use of data analytics inside Oracle Analytics Cloud and supplementing and using the features from Spatial Studio to help build a better data story. We're going to look at how we can move the data between the two systems and then look at something new for us, or at least for me, is the idea of a hierarchy of geography. So we'll be flipping between the analytics tool as well as the Spatial Studio tool and building a story based on a problem that we are going to solve, or maybe find information that in the data that we're finding is unique to our solution or our business issue. Again, this data is going to be all fake, but it has some purpose. So a little bit of overview on Oracle Analytics. From the life cycle that we look at from people working with Oracle data visualization, we're looking to gather the data. We do a little bit of cleansing, clean it up, maybe normalize it some, and then we start to explore it. We start to move things around. We look at amount by something else, by time, by location, by product group, or an entity. So using that gives us a place to start looking for those little bubbles that are nuggets of something outlying or clustering, or maybe something that's just caught our attention, right? So we use that portion to explore it. And then we get to the explain, where we build maybe a special canvas in DataViz that points out those key areas that we want to share, much like a PowerPoint, right? So that's the explain portion. And we're not going to do a lot on the explain, but the idea is that the explain portion, or the narrate portion of data visualization, is to really just highlight the key areas that we're trying to convey to the audience. Maybe give them something to take action on, right? So again, the two different types of data our data visualization is that exploratory versus explanatory. And if you are a reader or a follower of any of the people out there in terms of data visualization, Cole, Nussbaum, and Knaflic is big on the data explanatory. How do we tell the data story? How do we highlight those pieces and kind of push back to the parts that those data elements that are maybe not as important, but we still want to show them. So 2 different schools, 2 different methodologies. Today, we're going to primarily stay on the exploratory. So I like to attribute data visualization as kind of the gather, the cleanse, and we have a final product. So this is just a quick picture that just, again, maybe sharpens that message. We're going to do some digging. We're going to do some cleanup. We're going to refine it to a better data piece, and then finally give you that end product. For those of you who are, again, maybe new to Oracle Analytics, we connect to well over 30 different data sources, and then we have access to JDBC and ODBC, so or at least JDBC. So that even extends that connectivity further. And now the ability to make connections on REST, which came out later this, or mid last year, or I think it's still in preview mode. But we have a portion in the data inside DataViz, which is the data prep. That's that cleansing. That's the cleanup. Maybe normalizing a little bit, setting our some of the attributes to the data, or maybe splitting out like a date into a month and a quarter. So we have that ability to clean up the data and make it useful, and maybe not have to rely on a full ETL process. So this gives us a better chance to fix those pieces of the data that we need. And out of the box visualizations, well over 40. It's a great tool for trying to look at your data in different ways. And we're going to be working with, of course, the map layer, which is the one on the left or the far right. And we may use some of the other ones to help tell the story to the map. But that's our big one right now, is the map layer. And then, of course, the extensions. We can add customs. So there's a whole library out there from Oracle on custom extensions to expand your visualization story. So once we have all of that, we put it together on a canvas, and we use that canvas dashboard, project, workbook, whatever you want to call it, to give us the information we're looking for. This would be more of an explanatory rather than exploratory, because we're giving the information on the topics that were critical to that question. So with that, David.
All right, thank you, Wayne. Can you hear me okay? Just making sure.
Good there.
All right, cool. So with that introduction to Oracle Analytics, I want to do something similar just quickly for the Oracle Spatial sort of side of things, and just provide a quick introduction. So first of all, when we talk about spatial, we're just talking about, in general, about location information. This really has to do with any information tied in some way to location. And if you think about it that way, you'd be hard pressed to really come up with any business information that doesn't in some way fall into that category. Incidents, events, activities, transactions, really everything that we manage at some level can be tied in some way to location. And so these could be represented by points, lines, polygons, as well as spatial data like imagery and 3D data like LiDAR scans and services and connected networks and so forth. So it's a very wide net of data that falls under the spatial category. For what we're going to be doing, we're going to sort of bring this down to some very like basic intuitive examples, but it's a wide net. And Wayne, if you advance. The reason that we do all this is because spatial data and location is a really tremendous way to create associations and relationships and really sort of join and relate data where there is no other sort of simple natural way to perform such joins. So what I mean by that is we can join and associate data based on proximity, based on containment of incidents or events within areas. And lots of other examples where the only really effective and natural way to associate and join otherwise unrelated data is based on their spatial relationship. So Wayne, if you advance, now, that sort of putting that together in terms of how almost all data has some spatial aspect, and the ability to relate data based on location is really powerful. That's where our spatial platform, really where it sits. So you see sort of on the left are all these forms of spatial data. They are all stored and managed natively within the database, surrounded by APIs that let you all ask all kinds of questions. And then over on the right, we can see that how those questions can be asked, how you access those spatial features. Well, if you're a coder or a developer of any kind, anyone that's sort of technical, you just do it the way you would do any other work with the database through SQL queries. Or if you're a Python sort of data science person working in a notebook, you access the database and do the same thing. There's Java APIs and so on and so forth. Lots of development-oriented programmatic ways. But on the right underneath that, you see there's also something called Spatial Studio, which we referred to, and that's the self-service no-code sort of drag and drop way to work with these spatial features. And that's going to be the focus of what we talk about here. Now, this slide is actually calling out the fact that what we're talking about here with spatial goes for any Oracle database, but in particular, Oracle Autonomous Database provides all these capabilities. And so the ability to have all this in a fully managed database is really a tremendous environment to be able to go ahead with the kinds of things that we're talking about here. So Wayne, if you want to go ahead, just as a very basic example of using these spatial features just from the basic SQL sort of perspective, here I've got a set of retail store or branch locations and a bunch of warehouses, and I want to know which of those branch locations are within a certain distance of, in this case, 50 kilometers of one of the warehouses. It's just a proximity-based question, a SQL query, and a response. And it's really an example of that way of associating or joining data based on location, in this case, proximity, that I talked about earlier as being like sort of hallmark of what spatial is all about. But that's how you would do something, ask a question like that just at the SQL coding level. If you go to the next slide, Wayne, we can see that Spatial Studio tool that we've mentioned is the way to ask those same kinds of questions and actually visualize the results and share the results. It's a way to do that same thing, but without having to know or understand any of the SQL, any of the fact that there are these APIs in the database and so forth. It's really self-service, drag and drop, very much like the OAC self-service sort of thing, but specially tailored to sort of the spatial side of things and using all the spatial features of the database. So Wayne, you can move along, and I think that's sort of the quick introduction to the spatial side.
Good deal. Thank you, David. So we're going to start talking about our data story, and David and I presented on this topic. Now, this is our second version of this of Oracle Spatial in use with OAC. So back 2 years ago, we presented on just this St. Louis metro area and some flood risks and properties and what might be impacted if the waters got over a certain level, using some data from Missouri's floodplains and then again, spatial relationship. So this year, or this presentation, we're looking at a different set of data. We're going to look at the whole state of Missouri. Again, this is demo data. It's manufactured to help our story. I went and got some random sites within the state of Missouri. So we're going to look at some customers. We're going to put some fake sales data on with these customers, just to look at where they're at. And then we're going to be also looking at bringing in some supplier content as a component. So here's my customer. We're doing a little bit of data prep. Again, changing things off of something that might be summarized to something that's a join column. So my customers to my customer sales. And within OAC, we're able to kind of create these data sets by joining database tables, building pretty much a sort of mini data mart, if you want to call it that. So again, looking at the cleanup, We can take and apply location to that which is a location type element. So in this case, the state. We can do that again also to the county. So now Oracle Analytics will instantly know what to do with a county. And there you see the counties in the state of Missouri that matched to those customers. We could do it with the city as well. We'll just save the data set. And we now have something to work with. So again, a quick performance tile tells us how much money we're working with. We can do some formatting, some data cleanup on display. Again, making it easier to tell that story. Now, if I click on the county name and bring sales and allow it either to pick the best visualization, or because there's a location component to it, Oracle would actually assign it to a map. In this case, we're doing just the best, and we're getting pretty much too much data on this screen. But looking at it maybe by county, it's a little bit cleaner, right? Again, sort high to low, make it easier for your user to understand where that high point is. And in this case, we just asked to build the map on county name. And because the county name is across the United States, we need to tighten that up and put the state in with it. So that brings us into Missouri. And now we can see our counties to the state of Missouri, and then the sales by, again, county area, right? So, and then we have the brushing that allows us to look at that relationship of that element that you just clicked on to the map. So now let's take a look at possibly bringing in another bit of data into a new data set. And we'll look at our suppliers. Now this supplier list, again, it was just some random data points I created on maps to give me longitude and latitude and an arbitrary ID. All right, so there's my longitude, my latitude. And I don't want them as measures. I need them as attributes as well. So now my suppliers are on a completely different data set down in the left. It's not connected. And this is the nice thing about Oracle Analytics, is that I can build map layers that are on top of each other. And in this case, now I can see my suppliers on top of my sales. And we can, again, toggle layers on and off. So it's time for David to take over on the story.
All right, thanks, Wayne. So with that sort of initial data preparation done, we're going to kind of move over to Spatial Studio to really do all the rest of the spatial data prep in order to provide what OAC needs to take it and run with it. So the first thing we're going to do, and you can go ahead with the, this sort of outlines what we're going to do. We're going to start with geocoding, geocoding the customers, each of the customers, so that we can get them on the map. And let's just start with that. So as we see in Spatial Studio, we are going to grab or create a new Spatial Studio data set, which is really just a pointer or a reference to some data in the database. And we're going to navigate to our customers.
Running. Yeah, sorry.
Yep. Okay. So there we have just a table of customers that includes addresses. Very first thing we need to do is to set a key column, just a unique ID, which Spatial Studio will use for a variety of purposes. And then once we've done that, we're going to geocode those addresses to get their locations. We will use the option to also generate coordinates in addition to a geometry. And then Spatial Studio figures out which columns have the information needed for geocoding, street name, zip code, etc. Studio figures that out. We validated that it picked the right columns, and we let it run. So the Spatial Studio is pushing all of this data from the database through our hosted geocoding service. It's sort of giving us, letting us monitor its progress. And when it's done, it will have added a geometry column as well as longitude, latitude columns to that data set. And the longitude, latitude columns are really helpful because OAC can use them directly to put them on a map in OAC. And we can, of course, use the geometry to do spatial analyses in Studio. So now you see there's a pin icon for customers. And let's go back and look at what happened. Well, it's telling us that out of all the input data, they were all geocoded. And some of them, the ones that are listed here, had some type of issues that we automatically corrected, but they were all geocoded. So now we're going to put the customers and the counties into a new project and just get a sort of a sanity check and confirm that the geocoding worked to our satisfaction. So here we see all the county boundaries. We see the customers. We're going to flip their order so that the customers are on top. And yeah, everything looks like it's where it should be. We can always go back and look in detail at any the issues that were reported, make sure we're happy with the results. And when we look in here again, the longitude and latitude columns and the geometry column are all newly created by the Spatial Studio process, sort of an enrichment, if you will. And if we look in the table in the database, we can see that if we refresh, there is now a new geometry column and new latitude and longitude columns, which again, longitude and latitude are a sort of a convenience to allow you to drop these right into a OAC map. This is probably a good time to mention, Wayne, before you go to the next demo, that currently OAC does not natively support this Oracle Spatial Geometry data type. In order to do maps in OAC, it will either use coordinates or create a custom map layer, which is something that we're going to do in a couple of minutes. OAC, the roadmap for OAC includes support for this data type, which is only going to make this easier because that geometry data type will be able to be dragged directly right onto a map. So it's fine and works very nicely as it is now, but it's only going to get easier. So now that we've done that, Wayne, we can go to the next step. We've geocoded our locations and we're happy with what we see. So the next thing that
we didn't get the next slide. Here we go.
Yeah, okay. And so this is just now showing that data, the results of our geocoding dropped onto a map in OAC, because it's, what we did was just add columns to a table that OAC is reading, and there we go. So we've sort of connected the wires from that geocoding. Now we're going to get into creating these custom regions that are built from county boundaries. So you can start this one, Wayne. So here we have the source for the county boundaries, just open public data. And we will show just how it is that we take that public data and get it into Studio. So it's exchanged or provided in a shapefile format, most common format for exchanging spatial data. We can load that right into Spatial Studio. And when we do that, we will give it a nice friendly table name, and we'll use the same name as the data set in Spatial Studio. It's just a reference to that same data. We will also tell it what connection we want to load it to. So we're going to use one database connection for all this data, take a quick look at what the attributes are, make sure it looks like it's reading everything correctly, which it is. So it's just got the county boundaries and some demographic data, and it's now loading that data, that spatial data, into the database, automatically creating the geometries. And all we have to do now is to define the key column for that data. That's not part of the shapefile itself, but we know that a county FIPS code is unique. So now we have county boundaries ready to go. We'll take a quick look and just confirm that that they look right. And so that's really all there is to getting administrative areas and getting them loaded and ready to use. And we're going to save our work right now as a project that we will then come back to in a moment and add to. This will be sort of our working area in Spatial Studio, where we can continue to do our work, maybe take a break, come back and pick up where we left off. Loading that data in Spatial Studio, again, just created a table in the database, and there is the table, and it has the geometry column and all the other attributes. As I mentioned before, this is something that currently, to get this into OAC, we will end up pushing this out as a GeoJSON file to load to OAC to be able to visualize. Going forward, once again, it's just going to get easier such that OAC will be able to use the geometry itself. So let's go on to the next step, which is where we're going to build custom regions out of that set of counties. So go ahead with the next one. Now, as you start this, Wayne, if you don't mind just pausing for a moment right now, just pause the video. And I just want to mention that that we're always updating and evolving Spatial Studio, and all of the demos and things that you're seeing have been showing the Spatial Studio version that Wayne and I have been working on for the previous versions of presenting this. One of the important new features that we've just released in Spatial Studio 22.3 that was released late last month, is a simplified approach, a simplification of how you create custom regions. And when we described this process previously, there were some manual steps that had to be done to sort of get a set of custom regions fully built. And in the latest Spatial Studio, it's greatly simplified, which is what I'm showing you now. And I mention it because the UI that you see, the Spatial Studio user interface, you may notice it looks a little bit different in this particular demo piece. And that's because this piece of the demonstration is showing a feature that is in Spatial Studio 22.3. So with that said, Wayne, you can go ahead and now play it. We're looking at all the counties. We want to create custom regions based on them. So I'm going to start by selecting out the set of regions I want, the set of counties for the first region, and I'm going to say create custom region. Now we've introduced the option to say this is a brand new table and data set and everything. So I'm going to have Spatial Studio create it from scratch for me. It's going to be a brand new database table, a brand new Spatial Studio data set, and I'm going to define what I want the key to be. I'm going to call it region name. And this first region is going to be the Northwest region. And that sort of bootstraps, if you will, the whole process of not only combining the regions together, but building the new target of custom regions. So here's our new custom region data set. We didn't need to leave Spatial Studio for any of this. And there it is now in our project. If I drop it in, there's the first one that we just created. And that's it. Now we can just continue along. Now let's create our second custom region. So now I'm going to select out the items in the counties I want for my next region, and I can manually pick an additional one so that they're completely selected. And now I want to create another custom region for this set of selected items. Now this time I want to append them to an existing data set, which is the custom regions I just created. I'll simply give it the key. In this case, this is the Northeast region, and go. And that's it. Now we're pumping another custom region in, and I'll just continue to do this, and we'll fast forward through how I've done a bunch of them now down to the last one. So now we'll select across and get most of them, and I think I'll need to manually grab the last one. And now let's create our last custom region. And once again, of course, we're appending this into the one that Studio already created for us, and this will be the Southeast. And then once this is done, we'll run it. And then we will have a complete set of custom regions. We can then sort of turn off the underlying county boundaries, and we'll be looking at only the set of custom regions. Now, the whole purpose for this is really all about creating the spatial artifacts or the spatial definition of a geographic hierarchy based on sort of building blocks. And we're only doing really like a 2-level hierarchy. It goes from counties up to these regions. It could have been any number of levels that we like. This could be a 4, 5, 6, 7 level geographic hierarchy built on whatever we want. Instead of counties, it could be built off of postal codes. It could be built off of whatever you like. And then once we do this, the next step is going to be to sort of complete this hierarchy by creating the association between every county and the region it's in, because that's what allows OAC to do sort of the roll-ups and the drill downs. So Wayne, we can go to the next one. So this is just a depiction of what I just did using this new feature in Spatial Studio to simplify custom regions. So we'll go on to the next piece. So now that we've done that, we want to create what I think, Wayne, you refer to often as sort of a bridge table or a bridge data, the way to relate every county with the region it's in, so that that hierarchy is understood and can be used for roll up and drill down. So let's go ahead now, and we're going to do that essentially spatial join using Spatial Studio. So we're going to take once again, our counties and our custom regions. Now you see the UI looks like it did previously. We're sort of back to the UI from the earlier versions, but the process I'm showing here is exactly the same as it is today in the current version. So now we have our custom regions, and we're going to do an analysis, and that analysis is going to be to do a spatial relationship analysis between our custom regions and the counties. And so we want to look at each county, we want to relate them to the regions, and then the relationship we're interested in this particular case are where the region, the county is completely inside or covered by, meaning it shares an edge with the county. So nothing that overlaps, or shouldn't be any that overlap, and nothing that's sort of outside and just touching the boundary. We only want ones that are inside or just inside sharing an edge. And we're going to include for every county the key of the region that it's in. And that's what basically gives us this hierarchy. Now you're going to see the keys here that were used are going to be, I said Northeast, Northwest, and these are going to be keys that are 01, 02, 03, because that's what we did previously when we did this, built this example. But as we see now, here are the counties. And then with each of these counties, as we scroll, I think we scroll over to the right, we are going to see a new column added, which is region ID. That's the enrichment. The enrichment here is that we've tagged each county with the region, the custom region that it's contained by. That, of course, is what will allow OAC to be able to do the aggregation, the aggregating and the drill down and so forth. So I think that, Wayne, is I believe that's it for this guy. Now we've created our custom regions. We've associated every county with a region so that we've got that hierarchy built. So you could
we get a little bit
now,
yet
yeah,
to
we're
go
just so yes. So now we're going to okay, so now what we want to do is save. We're just, as a convenience, we're going to save that join that we just did as a table so that OAC can access it. When we do an analysis in Spatial Studio, the analysis is just known by Spatial Studio, but we can save it as a table or a view. And we've just decided to save it as a table. It could have been a view. But once it's a table or a view, OAC can access it. So by saving that result of that spatial join we just did to a table, in this case, again, could have been a view. This is now a database object that OAC can access so that OAC can see what you're looking at right now. So for every county, it can now see both all the county information as well as the ID of the region that it's in, and that will allow us, because we also have the shapes of those regions, to do map-based roll up and map-based drill down and summarize county information by region. So yep, this was so just basically saying that every one of the counties is also represented in this spatial join. They have the same number of rows. Every county got tagged with the region that it is contained by. So I think that now sets us up for doing the last sort of, I'll say, spatial enrichment in Studio, and that is that we want to do, we've already enriched the customers with the region that it's in. Now let's enrich the customers by identifying what the nearest supplier to each customer is, and I believe how far away that supplier is. So this, again, think of this as a spatial enrichment that will be able to be consumed by OAC and combined with all the other sort of data elements for analytics. So to do that, we're going to do an analysis between our customers and our suppliers. So we'll just start by dropping everything onto the map, and then we will do an analysis. And the analysis in this case is going to be one of the analytic analyses, as we call them, which is to find the nearest per item, where we want to find for each customer the nearest supplier. So for each item in customers, find the nearest supplier. We want to include all the information about the suppliers, and in addition to which supplier is nearest, we want to know how far away it is, and we can specify the units of distance we want, which in this case will be miles. So that's all we need to do. That's going to just create a spatial, in this case, it's a nearest neighbor. It's sort of a nearest neighbor join that is created, and we're going to call our result customer nearest supplier. So that will be the name of the resulting analysis, which again is an analysis that will be sort of understood and managed by Spatial Studio. It's based on just running a spatial query in the database. And we can look at the results. It could be, we could look at them on the map. We could look them in a table. We're just let's look at the results in a table view. So these are now again, the customers that have been once again enriched, and this time they're being enriched with this location analysis, nearest neighbor analysis result. So if we were to scroll over, we'd see that for each of these customers, there is a new column with this ID of the nearest supplier and the distance from that nearest supplier. I think if we scroll over, we will eventually see that. So there's a supplier ID, that's the nearest supplier, and there is a distance, that's the distance in miles from that particular selected customer to the nearest supplier. So brand new generated sort of attribute and metric for OAC that's been created by a spatial analysis. So we're just going to now save our work if we wanted to revisit it. But the key thing now is going to be to take this analysis and save it off so that OAC can access it. So this again could be a view, it could be a table. The nice, the advantage of a view is it will always be current even as data changes, and a table in this case is good as a snapshot. So in this case, we're going to save our result as a table for access so that OAC can access it. So now OAC knows for each customer the region it's in, and it also knows for each customer what's the nearest supplier and how far away is that supplier. And we're now going to look at that data in the database that was just created. In this case, it was a table, and there we see the data for every customer. We have all the original data plus the ID of the nearest supplier, and we included all supplier attributes. So we have its location and the distance to that supplier. So that's really all of everything that we need on the sort of the data analysis enrichment side. Actually, yeah, one other thing we're going to do. Suppliers, all Wayne did was create some random locations for the suppliers as coordinates. So let's actually figure out what addresses those coordinates resolve to. And that would be very nice to have in OAC as well, to have all the, city, know the city and the postal code and the street that they're on. So reverse geocoding is one of the other features of Spatial Studio, and it allows us to push through point locations through our hosted service and get back what address is that location at. And so what you're going to do in this case is, whereas before we started with coordinates and we were able to enrich it with address information, we're going in the reverse direction. We're starting with um, uh, I'm sorry, before we started with addresses and got coordinates, now we're starting with coordinates and we're getting addresses. So we've pushed our coordinates through the reverse geocoding process. We see that it's complete. So now if we look at that supplier table, we're going to see a bunch of new columns have been created. And we see the street number, the postcode, city, all that stuff was just generated by reverse geocoding. And if we take a look at that table in the database that was previously just supplier ID, longitude, latitude, it's now um, just additional columns that have been created that are ready for OAC to run with. And I see one question coming in, which is I appreciate, because I should have mentioned that there's no extra license, no extra cost, no extra anything for any of this geocoding and reverse geocoding and base map stuff that you see in any of this. It's all you're entitled to access to those features by virtue of working with the Oracle products that use them. So nothing extra to license or pay for with anything that we're showing. So we have now all these additional attributes that are readily accessible by OAC to run with for further visualization and charting and joining and all the cool stuff that OAC does. I believe now, Wayne, that the last thing will be to push. Yes. So now when it comes to points, longitude, latitude's all you need in OAC to drop them onto a map. But for polygons, like our custom regions and counties and lines, we need to export as a GeoJSON file that includes, of course, the geometry, but also whatever columns we want to use as keys in OAC to uniquely identify those shapes. That's all we do. So we've got the county name and the county FIPS code, which means that in OAC, if I drop county name or FIPS code onto a canvas, OAC will know how to put it onto a map. Same thing for our custom regions. We're going to say region ID, region name as the possible keys to use, and we save it as GeoJSON. And then we will, after this, get those GeoJSON files loaded into OAC as custom regions. And once you do that, then we're ready to, OAC is ready to automatically visualize all of these different regions, counties, and these custom regions we created, or any other shapes that you needed. And I just want to end this bit by saying this whole thing about longitude, latitude columns and GeoJSON and export and pick the keys. That's all, it does work, as you're going to see here, very nicely. And it's been working for a long time and lots of people are using it. But once again, it's just going to get easier and smoother as OAC completes its support for the geometry data type, at which point all you'll do is drop a geometry column onto a map. And I believe that's the transition back to OAC.
Yeah, my turn. David, thank you. You've set us up for a great way to work with this data. So we've got a few more slides and demos to show you, and we are running into the last 9 minutes of this presentation, so we may actually go a little bit over. So again, those two JSON exports that David did from Spatial Studio, we can just now add them into Oracle into the console. So there, we extracted the zip file, we got a JSON file, we're uploading it, we tag it, what are the keys that we're going to use to possibly join from our data. So there goes our custom region. And now we'll go pick up our Missouri boundaries. We could have just loaded the full US boundaries for counties, but I didn't want to have to to worry about all that extraneous data. So we're looking purely at Missouri for this data set. So the map zooms in purely to that level of view. Again, we can take a look at the data, inspect it, check our layer keys if we maybe needed to change one out of that. But we're ready to work with it. So expanding the data set, we had our customer sales, we had our customers, and we're going to bring in some of those other pieces, the suppliers, and looking at the nearest supplier join. Again, we've just basically created a new kind of mini data mart out of the tables that were generated from Spatial Studio. We can again see this longitude and latitude. You can see our counties, telling it that whenever a county is applied to the canvas, that it will link it to Missouri County boundaries, and you can see that we have 100% confidence on that join. Again, sometimes the data comes in mixed case, so the one thing I had to do was actually in one data piece make sure that it was all uppercase. Here's our supplier IDs, our distance. We don't want to be accumulating distance, so we'll set the distance to be an average, so we can look at the distance by supplier. What's their average distance to customers? And then here's that bridge table, as I call it. That's our link between the regions and the counties. And then there's our region. And whenever the region name is used, I want it to instantly go to the map that's been designed, that map layer that was created from Studio. So here again, I've got the mixed case for county as well as the uppercase, doing a little bit of cleanup on the data prep, things that just make the data more clean. And we're back to our model and the profiling of the data. So guess what? It's no demo. This is live now. We're going to go without the net. And this is where we have fun. We can think about the question that we want to do with this data. And to just show you that it's not that difficult to work with. So there's our region, right? This was the canvas that we had previously started with. And we'll just bring a new canvas and start thinking about the question. We've got our suppliers, right? And we can look at suppliers and their distance. So again, we're kind of generic with the supplier ID. And again, if I bring in the county and change it to a map, we can look at our suppliers. We got to swap these around because the location's based on the supplier. So actually, those are the data points or the counties in which the suppliers are in, right? So if we take that away and bring in the longitude and latitude, now we can see our suppliers throughout the state. and we can create another map layer just to kind of give us the boundaries, right? So this layer is going to be the county name. And we can, those are the counties that actually had the data in it from the join. And again, play around with the layers. We can bring this one to the back so we get everybody behind. And we can see the suppliers around through that. So maybe we want to look at another layer with our customers on the county. So since we now have longitude and latitude for the customer, let's add another layer. And we can put the customers. So you can see where all the customers are. And related to all the suppliers. And if we want to put the suppliers to the top, we can move that layer. And now we start asking the question, well, we've got such a density, maybe we need to change out or add another supplier to this area that might help alleviate some stress that's possibly on it. There's, again, the regions that we added to the map could tell us something about the data. We can create another map layer just by the regions, or we can swap out the county boundaries with the regions. Now I've got a bad data join in here, so we lost some of our data, but you can see we can start to look at just by the region what data elements may be in relation to that. And we're bumping up against the near end of the presentation. So I want to leave time for the question and answer. But the idea is that we can do some really quick and easy analysis using all of that joined data and the data that David created in Studio becomes data that we can consume in OAC. So without further ado, let's go back to the deck and a little bit of our closing thoughts, and then we'll go to the Q&A. And of course, it's not going to give me the right slide. So I'm going to leave the end of the deck with a whole bunch of links to some of the data I used, or some of the source data, some boundary layers, things that are available from Oracle, from custom regions. There's a whole bunch of regions out there. Location is not just geography. Think about that. Location can be the floor plan of an office building or a hospital. Maybe you want to analyze time in patient rooms, right? If you're tracking that kind of information with doctors tagging in and out of a patient room, we can look at time in rooms, time at workstations, things like that. So remember, it's not purely a geographic to countries, right? There's some great tutorials in the Oracle documentation. And then David has a great live labs for Studio that is available out in the Oracle Live Labs section on Oracle's website. Some YouTube videos that were created from Oracle Analytics team related to using maps within OAC. And then some various map data sources and shapefiles that you can use to help enrich your data. And to that end, I'd like to personally thank David again for helping build this presentation and helping present with me today. This has been some fun stuff. I've loved working with spatial data. So we've got some questions. Is there an available is this available as a workshop to replicate this data and get trained? I would start with the live labs. That would get you trained or sort of trained on using spatial data and Spatial Studio. I don't know what SODA. David, do you know what SODA? SODA?
Yeah, it's related to like Oracle REST data services, simple. Yeah, I do. What was the can SODA be? Yeah, because of the
JSON data.
yeah, because OAC supports REST, in general, yes, Martine. I guess what would be, so if you mean specifically like use SODA and ORDS for integrating spatial data, SORD, GeoJ, yeah. So not yet. So it's a great idea, and it's exactly where like my head's sort of gone to be able to say, well, if OAC is consuming JSON via REST endpoints, then how about that for consuming GeoJSON without all this export import stuff? And the answer is not yet, but I think that's a solid idea, and the fact that you're mentioning it is great, because that's something that I can communicate. So.
Okay, not seeing any new questions. The only one was the workshop. That one I think we answered is to check out the live labs. David and our contact information is in the beginning of the deck. If you have questions, you can fire off questions to us. We do our best to answer. Without further, wait a minute. Does the data need to reside in ATP? We don't, I mean, I use ADW. I don't use ATP because, quite frankly, ATP is designed for different processes, but we can query ATP in OAC. It's just the database structure is a little different. Go ahead, David.
And all of the spatial stuff that we were talking about is, all, ATP as well. So there's nothing that we were showing that was specific to ADW versus ATP.
Okay.
So.
Get started with maps and spatial in Apex. Is that the live labs?
That's a different live labs. So if you just go to the live labs page, there's actually like a bit.ly link for live labs. Maybe you want to Wayne, just open up I don't know if you can just open up a browser and go to, I can just tell you the bit.ly link to go to. Just open a browser, we'll just do it. So in a new tab, just go to, it's bit.ly/go live labs, one string, bit.ly/go live labs. And then in the search workshops, just type spatial. And there you'll see Introduction to Oracle Spatial Studio, as well as some other ones. So that's sort of, I tend to find that the direct links are convenient to go right to it, but are also kind of long and complicated. But if you go to bit.ly go live labs and search, it's pretty easy to find stuff that way.
Good deal.
And if you're interested in Apex, definitely do the Apex one though too. It's sort of
okay. Insert live labs, that one. Thank you for the comments. Looks like that's it. All right, folks. This has been great. I appreciate you all spending your hour with us. And keep an eye out for future tech casts from Analytics and Data Oracle user community. If you are a person that loves to speak, wants to speak, has a great idea for a topic, we'd love to hear from you. Send a note to info@andouc.org and we'll be in touch. With that, thank you all. Thank you, David. This has been fun.